Hello everyone. We're going to take a look today at some measures of center. Specifically two that we've kind of talked about before already. We are going to be looking at the mean and median. So I have some numbers that are here. This is the stem plot that is found on page 39 in your textbook in chapter 2. Really describes how many minutes it takes for someone to get to work. So what I'm going to do is I'm going to take this thing and turn it sideways again, because then it looks a lot like a histogram. Really just remember when you're taking a look at this, this is saying between 0 and 10, and between 10 and 20 to 30 to 40. In between 0 and 10, there's just this one entry. In between 10 and 20, there's really, I think that's 6 of those entries. It's the numbers 10, 10, 10, 10, 12, and 15. All right, so we want to talk about finding these measures of center. A lot of people have really taken a look at what is the arithmetic mean or the arithmetic average of these numbers before, and we've done it a lot of times, and they sometimes probably try to get inside your head and say, here's what they've got for formulas for finding the arithmetic mean. A lot of people struggle when we get all this fancy notation in here, because each one of these numbers, these are like numbering the guys on a soccer team. Here's the guy wearing jersey number 1. Here's the guy wearing jersey number 2. Has nothing to do with how big or small or good or bad someone is. It's probably just their favorite number. So here are the numbers on the jerseys. And the reason they use N is they really don't know how many of those numbers there are. So apparently this is a soccer team with a very bad coach who doesn't know how many players are on his team. He's going to add together whatever they are. And so think about, if we're talking about the players, whatever the value I'm measuring about these players. Like maybe I'm averaging their weight. X1 is the weight of player 1, player 2, player 3, and I'm going to divide it by how many players I have altogether. So that's really what that notation means. This is X bar is how we say that. It's usually used to depict the average, and it's nice because if I have 2 lists of numbers, or even 3 lists of numbers, and say here I've got 3 numbers and 3 numbers and 3 numbers, X bar means I'm going to add 0 plus 1 plus 2 and divide by 3, whereas Y bar means I'm going to add 1 plus 3 plus 4 divided by 3. Notice, just because of the numbers that we have there. So if I am going to find the average of the data set that we have here, we are simply going to be looking at, get all this erased. We're simply going to be looking at adding together each one of these numbers and dividing it by the fact that there are 15 total. So that's your average or your mean. We talked about the median. A couple of things. Well, before we go to the median, one other way to see the mean given in notation is using the Greek letter sigma. Sigma really just means add all of them. Add all of them up. So, the Greek letter, it's a capital letter S, and usually I remember that that's sum, capital letter sigma. So you're going to take all of these guys, and they use this I here. And they're like, yeah, I don't know how many there are. I'm going to say, I always think of it as individuals, like each of the individual x's, x1, x2, x3, xn. And I would say I'm going to divide it by the number of them on the team like this. They just choose to show it as 1 over n times, because you remember that you can multiply by the fraction to get the same thing. So this is the same as saying add them all up and divide by how many there are. So that's what that notation looks like. You may see it in both formats, and a lot of times it depends on if you're reading a research paper and whatnot. So the next thing is taking a look at the median of the numbers. And we talked about there's a problem when you have the median if, let's say, these are the 4 numbers that I have, and I just picked 1, 2, 3, and 4. Because this is even, I end up running into a problem. If I have 5 numbers, it's no problem, because here is the middle number, because notice 3 is right into the middle. All right, so that's the median. one of the nice things about the median compared to the mean is that if we get a data set like the one that we were looking at before, this data set is kind of skewed. If I look at it, it's like I've got this data that's skewed off to the right because of this outlier that's here. Well, the mean tends to follow that tail, which means our mean is most likely going to be a little bit further to the right. The median does not. So our median might be over in here, and we'll figure out that when we get to it. But the median does not get influenced by those outliers. It's a true measure of the middle. So we'll talk a little bit about that. But here we have it with 5 numbers. Really cool trick that they point out in the book that, again, is you can always find the median by finding how many numbers, adding them, and then dividing by 2. And that's going to be, which item is the median. It's not going to tell you the value, it's just going to tell you which item. So for example, in the case here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 15 numbers. So I can do 15 plus 1 divided by 2, and it comes out nice and even. It's going to be the 8th number. And if you think about it, here's the number 1, 2, 3, 4, 5, 6, 7, 8. Here's my median. It comes out evenly. I've got 7 numbers below it and 7 numbers above it. All right, so the number 20 is the median. I'll do that with that smaller set of numbers here. This is 5 plus 1 divided by 2, and we end up with 3. All right, again, it doesn't matter if the numbers are 17, 23, 84, 96, 105. If they're in order, 5 numbers, so again, that's why n equals 5. There's 5 numbers, so 5 plus 1 divided by 2 gives us the 3rd number, 1, 2, 3. Well, how does that work if we're using an even number of numbers? Well, let's say I have these, 17, 24, 16, and 50. First of all, because I was saying them as I went through here, we have to put these in the right order. So we need this 16 and this 24 have to switch places. So first of all, we're going to get that. Oh, and the 17. Man, I was really counting wrong. So 17 has got to be put in the right order. So let's get those in order. And then we've got n. N equals 4. There's 4 numbers. So we're going to do 4 plus 1 divided by 2. Notice 5 divided by 2 is 2.5. Anytime I get that 0.5, I know I'm going to have to find an average. I need the number between 2 and 3. So here's x1, here's x2, here's x3, here's x4. Well, I don't know what the number is between these two, so I actually average them. 17 plus 24 end up with 41 divided by 2 ends up being 20.5. So really cool trick using the median equals n, how many numbers, plus 1 divided by 2. It'll always help you find it pretty quickly. Again, like I showed you in the videos last week, it's really tedious to do those things by hand all the time. So in a lot of cases, we use the software to do the mean and the median. But we're going to investigate, we're going to take a look at some data sets and see how that mean gets affected by those outliers so often. So we'll be taking a look at that in our next video.